Welcome to qnawire.
So right here we're going to have the half-life of Tc-99m that is going to be equal to 6 hours. So the half-life time is equal to 6 hours. And we want to know how much of a 199 milligram sample will have decay after 30 hours. So one of the ways that we can do this is if we divide the number of hours that have passed by the half-life time, we will realize that this is equal to 5 times the half-life time. So we're going to have a decrease of 0.5 or of 50%, 5 times. So the total amount that we're going to get is equal to 0.5 to the 5 times the initial mass. This is going to give us that the mass after 30 hours is going to be equal to 6 milligrams. Alternatively, we can solve the kinetics equation. We know that the half-life time for a first order reaction is going to be related to the rate constant as follows, as logarithm of 2 divided by k. So the value for k is equal to the half-life time. Sorry, it's equal to logarithm of 2 divided by the half-life time. From here, we can replace this value into our exponential equation. We know that the concentration or the amount of substance at a certain time t is going to be equal to the initial concentration times the exponential of minus kt. Replacing the value of k and plugging in here the initial mass, that is 192 milligrams, we're going to get that after 6 hours, we're going to have logarithm of 2 divided by the half-life time times 6 hours. Remember that the half-life time is equal to over here, times 30 hours. And over here, remember that the half-life time is going to be equal to 6 hours. So this becomes 192 milligrams times the exponential of minus 5 times the logarithm of 2, which gives us exactly the same result, 6 milligrams. So how much of the sample will have decayed? The amount that decayed is going to be the initial mass minus the final mass, which will be 192 minus 6, 186 milligrams. How much is left, or the amount left, is going to be equal to 6 milligrams. So those are the two methods that we can employ. In this case, it is simple to get the result since the amount of time is a multiple of the half-life time. But we can also solve the kinetics equation and get the result as a function of time. So that would be all. Thank you very much and have a good one.